Using significant figures, or actually more appropriately, significant digits, when you're adding and subtracting is a lot harder than when you're multiplying or dividing. And I thought I'd go over a couple examples here to illustrate how it works. So here are two operations, an addition above and a subtraction below, that are good examples of how sometimes using significant figures can be counterintuitive when you're adding or subtracting. So let me quickly, let's just look at a number here and just remember what we mean by significant numbers and significant digits. Okay, here's a random number, 321.58. And obviously we know the number of significant figures here. We can count them. There are no zeros, so we don't have to worry about that. And there are 5 significant figures. But for the purposes of adding and subtracting, that's not important. Okay, it's not the number of significant figures that's important. It's actually the least significant digit. And the way I like to think about that is in terms of the implicit uncertainties. So remember how the implicit uncertainties work, right? If this here is the hundreds place, right? The hundreds, let's just go over the places. That's a hundreds place, tens place, that's the ones place. This is the tenths. Tenths, and this is the hundredths place. And the relative uncertainties here, will be half of each of these places. So if the least significant digit is in the hundredths place, we write plus or minus 500, 50 plus or minus 50. If it's in the tens place, it's plus or minus 5. Ones place, we'd write plus or minus 0.5. Tenths plus or minus 0.05, and hundredths we'd write plus or minus 0.005. Now for this particular number, right, the least significant digit is the hundredth place. We circled this in one of the activities we did in class, right? So this is the smallest significant digit, and the relative uncertainty will be half of whatever this digit represents. Remember, this is the hundredths place, so half of that is 0.005, and we would write this number then as 321.58 plus or minus 0.005, right? Get rid of plus or minus 0.005. So again, just to remind ourselves, when we say 0.005, that says that the least significant digit is in the hundredths place. All right, now the rule when we add or subtract is we look at our two numbers and the result will have the relative uncertainty of the larger of the two relative uncertainties of our numbers. Just for example, so if I'm adding 3.0 plus 11, I'm going to add these two numbers together. We go through and circle them. The small least significant digit with 3.0 is in the tenths place. The least significant digit for 11 is in the ones place, right? So this would imply plus or minus 0.05. This implies plus or minus 0.5. The larger of these two relative uncertainties rules the answer. So in this case, it's plus or minus 0.5. And the logic is that this smaller relative uncertainty for this number gets lost within the slop of this relative uncertainty. So when I add these two numbers together, I would get, do it down here, I get 14.0, just without worrying about significant figures, right? But the answer is going to be ruled by the larger of the two relative uncertainties, and that's the 0.5, and that refers to this digit, the ones place. So in fact, this number should be written simply as 14. Right? 14 implies plus or minus 0.5. So once again, the larger of the two relative uncertainties here rules the answer between when we add or subtract two numbers. So let's do it here in these two examples I have above. Let's do the first one here. So once again, just remind ourselves there are two significant figures here, but we don't care about that for adding and subtracting. What matters is the largest significant digit. And I'll circle them here. So it's the 2 here and the 8 here. This implies plus or minus 0.05. This implies plus or minus 0.05. The ones place is significant, right? whoop, 0.05. The 10th place is significant. Sorry about that. Right? And they're the same. So when I add them together, these are the same number. So the 0.05 is going to work for the solution too. So when I add these two numbers together, I get 10. I'm just going to write the 0.0 here and figure out how many of these are significant. So remember now, it's the 10th place that remains significant. So in this number here, the result here, this is plus or minus 0.05 because, right, this is the same. Because these are the same, the result will have the same uncertainty. If they were different, it would have the larger of the two uncertainties, but they're the same, so it's the same. So this is plus or minus 0.05, which implies that this is significant. So all three of these numbers are significant. This number now has three significant figures. And the 0, it should properly be written just as I did it. 10.0 with three significant figures. And notice what's happened here. We've added two numbers with two significant figures, and we've created a number with more significant figures. That can happen when we add or subtract. Now, let's look at the second example. Do that here in orange here, okay? Second example, simple. 157 minus 156. We can do that math in our head. We get to 1, right? And now we just have to figure out, well, how many significant figures? Is it 1.0? Is it 1? What is it, right? Well, again, we're just going to simply apply the rule of, using for the result the implied uncertainty that is the larger of the two numbers. So this is 157 plus or minus 0.5, and this is 156 plus or minus 0.5, and in both cases it's the ones place that is therefore the least significant digit. It's the ones place that's the least significant digit. So again, we have 0.5 and 0.5, so the result is going to be 1 plus or minus 0.5, and it's the ones place that is the least significant digit. Oops. It's the ones place. So there are no more significant figures. The correct answer here is just simply 1. Just 1. And so here now, notice what's happened. We've gone from a number with, I'll write it in orange, 3 significant figures here and 3 significant figures here. And by subtracting them, we end up with a number with only 1 significant figure here. So the number of significant figures is not important, and it may increase or decrease as we add or subtract numbers. What is important is to identify the least significant digit, and the larger of the least significant digits is the one that rules the result. And another way of saying that is to identify the implied uncertainties of the two numbers, and the larger of the implied uncertainties is the one that rules the result.